California has the highest risk of earthquake losses in the United States. On April 4, 2010, a magnitude 7.2 earthquake struck Baja California, just 65 kilometers south of the U.S.-Mexico border. It was followed by a rich aftershock sequence that included a magnitude 5.7 earthquake on June 14th, just north of the U.S.-Mexico border. Then, on July 7th, a magnitude 5.4 earthquake occurred on the San Jacinto Fault near Anza, California. This northward migrating earthquake sequence raised concerns that a large earthquake could occur on one of the major faults in Southern California. At the Southern California Earthquake Center, headquartered at the University of Southern California, students participating in the Undergraduate Studies in Earthquake Information Technology Internship Program, or UseIT, utilize advanced visualization technologies to study this earthquake sequence. Using Southern California as a natural laboratory, UseIT interns collaborate with SCEC scientists and with each other to improve our understanding of earthquakes and their effects. Each year, SCEC Director Tom Jordan presents the UseIT interns with a significant geophysical challenge that the interns solve in the brief summer period available to them. The grand challenge for 2010 was to develop a seismic crisis visualization system based on SCEC's virtual display of objects. SCEC-VDO, as it is known, is an open-source application used to visualize earthquakes, faults, and other geologic data in 3 dimensions. Such a seismic crisis visualization system could be used to provide authoritative information on the time dependence of regional seismic hazards, a major goal of operational earthquake forecasting. In order to develop a system for visualizing seismic crises, the interns divided into 5 interdisciplinary teams: science research, software development, visualization production, content management, and media. A quality assurance team ensured close coordination between the teams toward Grand Challenge objectives. Each team tackled a different aspect of the Grand Challenge and then combined their efforts and results to create final products reflecting the summer's work.
So the science research team worked with the other groups because they had their own tasks to take care of, but before they could address their tasks, they needed background information about earthquake science and about the other things that they were dealing with. And so it was the science research team's responsibility to make sure that these teams had the knowledge that they needed to accurately and correctly display their information and do what they needed to do.
The software development team created 3 plugins for the operational earthquake forecasting. The science research team helped us a lot in understanding a lot of the file formats that we were given, because we were just given all of this data and we didn't really know what any of the scientific terms meant, so we just handed it over to them and they kind of explained it to us. I think a lot of the things we've done are like first time breaking things that have never been done before. So.
The video production team created animations about the 2010 Mayor-Cucapah earthquake sequence to demonstrate the northward trend of trigger events. The development group helped us implement relocated earthquake data as well as give us new plugins for animations related to the Grand Challenge.
The content management team mainly worked a lot with the development team and also the scientific research team because they gave us the information to kind of put on the site and we were just responsible for getting all of the content and delivering it through the site. Whether it was SCEC-VDO animations, the plugins developed by the 2010 development team, or also just updating the intern profiles and making the site a little more nice to work with.
The 2010 Grand Challenge experience was captured by the media team so that we could produce a documentary movie for the public to view. Creating this documentary video will allow us to show the public what SCEC and the UseIT program do to further science research.
The combined efforts of the interns further developed our ability to visualize earthquake information and to quickly make it available to a diverse audience, which is critical to improving operational earthquake forecasting. The enhancements made to SCEC-VDO this year include a real-time earthquake display of recent seismic activity around the world, the ability to visualize displacements on faults from simulated earthquakes, and the ability to display the probability that earthquakes of a given magnitude will rupture a particular fault. Using the information and tools created by the UseIT interns, communities around the world can have an increased awareness of hazards associated with earthquakes and can be better prepared for future earthquakes that could occur in their area.